in order to come up with a formula for the sum and difference of a sine function, what we're going to do is we're going to use the cofunction identity. So just as a reminder, sine of pi over 2 minus theta equals cosine of theta. Yeah? Or 90 degrees, however you want to write it. So, or cosine of pi over 2 minus theta equals sine. So what I want to do is I want to rewrite this in terms of its cofunction, right? So sine of u plus v is equivalent to cosine of pi over 2 minus u plus v. Okay, so sine of any angle is equivalent to cosine of pi over 2 minus that angle. So if theta is u plus v, then that's pi over 2 minus u plus v. So then what I'm going to do is I'm going to rearrange that a little bit. First I'm going to distribute the minus sign, so minus u minus v. And then I'm going to rewrite it as cosine of pi over 2 minus u minus v. And then I'm going to use the sum and difference for cosine and see what happens there, okay? So, cosine of the sum and difference, u plus or minus v, the sum or difference, equals cosine of u cosine v minus plus sine u sine v. Just as a reminder, that's our formula for cosine of a sum and difference, although pretty sure we used alphas and betas. So we said alpha plus or minus beta, cosine alpha cosine beta, minus plus sine alpha sine beta. Okay? So in this case, my u, or my, yeah, well, I'm going to go ahead and rewrite it, because I've already got u's and v's over here, and I want to be able to say that, what my alpha and my beta are. So alpha and beta, alpha and beta, alpha and beta. Okay, so in this case, the alpha is pi over 2 minus u, and the beta is v. So let's go ahead and fill it out. I've got cosine of alpha, which is pi over 2 minus u, times cosine of beta, which is v. This is a minus, so this is going to be plus sine of alpha, which is pi over 2 minus u, times sine of beta, which is v. Okay? And then, again, using my cofunction identities, I can rewrite cosine of pi over 2 minus u is a cofunction to sine of u. So sine u cosine v plus sine of pi over 2 minus u is a cofunction to cosine. So cosine of u sine v. So sine of u plus v equals sine u cosine v plus cosine u sine v. Okay? So if we were to generalize that into a formula, just like we have cosine of alpha plus or minus beta, we're going to have sine of alpha plus or minus beta equals. And so it's just sine cosine of the first and then the second. So sine of alpha cosine beta. This is plus and this is plus, so that stays the same. Plus minus cosine alpha sine beta. So if we keep the alpha beta, and then you just switch to sine cosine and then cosine sine, and then there's my two formulas. So I've got sine sum and difference, cosine sum and difference, and then in a minute we'll come up with the tangent. But in the meantime, let's go ahead and apply those right quick. Okay. So first I've got this problem. It says use the sum and difference formulas to write each of the following expressions as the sine and cosine of an angle. So first off, I see that it's sine cosine, cosine sine, which leads me to a sine. It's plus in the middle, and sine stays the same, so it's plus right here. And then my two angles, my alpha and my beta, are 22 and 13. 22 degrees and 13 degrees, which means it's really sine of 35 degrees. And that's all we do with it. We just write what it's equivalent to. So cosine of pi over 3 cosine of pi over 4 plus sine pi over 3 sine pi over 4. Okay, cosine, cosine, sine, sine is a cosine. Cosine, cosine, sine, sine. The fact that there's a plus sign in between them, remember, if it's plus here, then that means it's minus over there. So I know it's a cosine, I know it's a minus, and then my two angles are pi over 3 minus pi over 4. We're going to do common denominator. So I'm going to multiply by 4 on top and bottom, and I'm going to multiply by 3 on top and bottom. So it's going to end up being just cosine of 1 pi over 12. And that's what that is equivalent to. Okay? Now I've got sine, sine, cosine, cosine. Did I have it like that? Sorry, I'm going to check something real quick. I want to make sure I didn't write that down wrong. What else did I have? Interesting. Give me a second. My steer's wrong on this. Okay, cool. Just making sure. All right, so what I'm going to do is rewrite this in the order that I know it should be in. Okay, so I know it's cosine, cosine, plus or minus sine, sine, for a sine, some difference of a sine, right? So sine, sine, cosine, cosine. So let's go ahead and rewrite it as negative cosine x, cosine of 2x, plus sine of x, sine of 2x, and what we can do is we can just factor out that negative, and just so that we have that positive first term, and just say it's negative of whatever I get. So I'm going to rewrite this as cosine x, cosine 2x, and then this, when I factor out a negative, this becomes minus sine of x, sine of 2x. And so, rewriting it in terms of using our sine, it's a negative sine of, well, so in sine, so forget the negative out there. We're just dealing with this right here, right? In a sine, if it's minus here, it's minus there. So minus, and then the two angles are x and 2x. So I really get negative sine of negative x. 1x minus 2x is negative x. But if you remember from your even-odd identities, or odd-even, sine of negative x is equivalent to negative sine of x, because sine is an odd function. I flip over the y, same thing as flip over the x. So this really just equals sine of x. Where are you going now? Why? Okay. So that's the final answer for that. All right. On this one, so suppose sine of alpha is 12/13 for a quadrant 2 angle, and sine of beta equals 3/5 for a quadrant 1 angle. Find the exact value of the following. Okay, so I'm going to draw, well, I'll draw it over here so I can use it. Okay. I've got an angle in quadrant 1 and an angle in quadrant 2, so I've got an angle where sine is 12/13. It's okay if your triangle doesn't necessarily match the dimensions. Okay, sine is opposite over hypotenuse. 5, 12, 13 is Pythagorean triple, so this is going to be 5, or 169 minus 144 is 25. And then I've got an angle beta, and the, oh man, that was in quadrant 2. Dang it. Oh no, I got that messed up. Okay, so quadrant 2, there's alpha, this is 12, this is 13, and this is negative 5 because of location. And then I've got, in quadrant 1, I've got an angle where sine is 3/5, so 3 over 5. So more like this. And that is a Pythagorean triple as well, 3, 4, 5. Okay? So it says find the exact value of the following. Cosine of alpha plus beta. So cosine of alpha plus beta, I don't know even what these angles are. Let me label that as beta. So I can't really just like add up the angles and find the cosine of that, but what I can do is I can rewrite it. So cosine of alpha plus beta is cosine alpha, cosine beta, that's plus and this is minus, sine alpha, sine beta. And so all I really got to do is fill these in. Cosine of alpha is adjacent over hypotenuse, so negative 5/13. Cosine of beta is adjacent over hypotenuse, 4 over 5. Minus sine of alpha, sine of alpha is 12/13. And sine of beta is 3/5. So 13 times 5 is 50 plus 50, 65. So I've got negative 20 minus 36 over the common denominator 65, so the answer is negative 56/65. And that is what cosine of alpha plus beta equals. Now I need to do sine of alpha minus beta. So sine of alpha minus beta. So in general, sine is sine of alpha cosine beta, minus as well cosine alpha sine beta. Make sure on that. So the angles, they stay in the same order: alpha, beta, sine, cosine, cosine, sine. And I guess you can remember sine always starts with sine. Sine, cosine, cosine, sine. Okay? So then I can fill them in. Sine of alpha is opposite over hypotenuse, 12 over 13. Cosine of beta is 4 over 5. Cosine of alpha is negative 5 over 13. And sine of beta is 3/5. So again, the common denominator is 65. So I've got 48 plus 15 over 65. So it's 48, 58, 63. So the answer is 63/65. Okay? So the biggest thing is going to make sure that you draw your triangle in the correct quadrant, and then label any sides that are supposed to be negative as negative. Make sure you make note of that. Alright, I need to prove that this is true. So right quick, just do that little identity. Sine of alpha plus beta is sine of the first times cosine of the second. That's plus, this is plus. Cosine of the first angle times sine of the second. Sine of x is sine of x, and cosine of pi is negative 1. So we're talking about the value over here. Cosine of pi is negative 1. And then cosine of x is cosine of x, but sine of pi is 0. So this just goes away. My final answer is sine of x times a negative 1, which is negative sine of x. Okay. Now let's do tangent. So I want to know what tangent of alpha plus and minus beta is. Yeah? So what we're going to do is we're going to rewrite tangent in terms of what we know with sine over cosine. Sine of alpha plus and minus beta over cosine of alpha plus and minus beta. And then I'm actually going to fill that out. So I've got sine alpha cosine beta plus and minus cosine alpha cosine beta over cosine alpha cosine beta minus plus sine alpha sine beta. Now what we're going to do is we're going to divide, let's see, let me think about this. I want to get something involving tangents, and tangent is sine over cosine, so sine over cosine. So I think what I'm going to do is I'm going to divide by, I'm going to multiply top and bottom by 1 over this, and I'll explain why in a second, because like this, let's see, no, I think it's going to be cosine alpha, and then, let's see, cosine alpha, cosine beta, cosine alpha, cosine beta is 1. So, I'm supposed to get that to a 1, and that's supposed to be, oh, I know, I messed up my sign. I was like, what is wrong? This is supposed to be a sine. Sine, cosine, cosine, sine. There, okay. I was like, what is going on? So I want tangents in my expression. So like sine over cosine is going to be tangent. Sine over cosine is going to be tangent. Sine over cosine, sine over cosine. So if I were to divide this term by that term, then I would get both tangents, right? So this is just kind of a trick. It's not like it's something you're going to have to recreate. So I'm just showing you where it's coming from. So this is sine, or cosine. We're going to divide both numerator and denominator by cosine alpha, cosine beta. Cosine alpha, cosine beta. So I'm just going to rewrite it all, and you don't have to be writing this down. If you are writing it down, that's great, but remember this is just me deriving the formula, so you don't have to. So I'm just going to rewrite it. Plus minus cosine alpha, sorry, do it again. Sine beta over cosine alpha, cosine beta minus plus sine alpha, sine beta. Okay, and then I'm going to distribute my 1 over cosine alpha, cosine beta to each of these. So I'm going to divide by cosine alpha, cosine beta, cosine alpha, cosine beta, cosine alpha, cosine beta, cosine alpha, cosine beta. And then we're going to simplify. So this first one, the cosine beta simplify away, and I'm left with sine alpha over cosine alpha, which is tangent of alpha, plus and minus. Go like a tube. Okay. Cosine alpha, cosine alpha goes away. Sine beta divided by cosine beta is tan beta. All divided by. Something divided by itself is 1, so minus plus. And then sine alpha over cosine alpha is tan alpha, and sine beta over cosine beta is tan beta. So that is the formula for tangent of alpha plus and minus beta. So it's a little bit more involved than the others. You've got tangent of alpha plus or minus tangent of beta over 1 minus plus tangent of alpha tangent beta. Okay. And here we go. So I'm going to use that formula to determine what tangent of 13 pi over 12 is equivalent to. So remember, first off, I need to be able to come up with two angles that add up to 13 pi over 12 that I can simplify. So when I think about numbers that add up to 13, I get 1 12 plus 13, or plus 12 12s. I know what 12 12s is pi, but I don't know what 1 12 pi is, so I can't use that one. 2 12ths and 11 12ths, that's a no. So I don't know that one. 3 12ths plus 10 12ths. Okay, 3 12ths is 1/4, and 10 12ths is 5/6. Okay, so that's pi over 4 plus 5 pi over 6, and that would work. So those are two angles that add up to 13 pi over 12 that I can use because they're all in a circle. 4 and 9 would have also worked, because that's 1/3 and that is 3/4. So it's just whatever you see, but I'm going to go ahead and use this one. So tangent of 13 pi over 12 is equivalent to tangent of pi over 4 plus 5 pi over 6, although order doesn't matter, which is equivalent to tangent of the first angle, pi over 4. It says plus minus, so if this is a plus, this is a plus. Tangent of 5 pi over 6 over 1. This is plus minus, this is minus plus, so this is the opposite, 1 minus. And then the same two things, tangent of pi over 4 and tangent of 5 pi over 6. So I'm going to recreate my unit circle right quick, or at least the terms I need. So I need pi over 4, which is right there in the middle, and I know that tangent, when I have square root of 2 over 2 and square root of 2 over 2, tangent equals 1. And then 5 pi over 6 is this one right here. And if this is the coordinate point, negative 1, 0, if this is 0, then that's 1/2, and that's negative square root of 3 over 2. So tangent is sine over cosine, which is negative 1 over the square root of 3, or negative square root of 3 over 3. Okay, so let's plug them in. Tangent of pi over 4 is 1. Tangent of 5 pi over 6 is negative square root of 3 over 3. 1 minus tangent of pi over 4 is 1 times tangent of 5 pi over 6, which is negative square root of 3 over 3. Okay, I'm going to rewrite this as well, I'm going to simplify the negatives and all that, and then we'll deal with common denominators. So I've got 1 minus square root of 3 over 3 over 1 plus, because a negative times a negative, square root of 3 over 3. Common denominator will be 3, so multiply to add 1 in my 3. And then I've got 3 minus root 3 all over 3 over 3 plus root 3 all over 3. If I flip and multiply by the reciprocal, 3 over 3 plus the square root of 3, the 3 simplify out, and I'm left with 3 minus the square root of 3 over 3 plus the square root of 3. Now, that's fine as an answer, I think. Let's see, I want to explore if it would simplify much to do that. If I multiply top and bottom by the conjugate, so that I no longer had a square root in the denominator, then the denominator would end up being 9 minus 3 root 3 plus 3 root 3, those would cancel each other out, and then minus 3. So my denominator would be 6. And then the numerator would be 9 minus 3 root 3 minus 3 root 3 is minus 6 root 3, and then that would be plus 3. So that would be 12 minus 6 root 3 all over 6, which, yeah, we would want to simplify to 2 minus the square root of 3. And that would be, I think that should be our final answer. And we multiply by the conjugate of the denominator so that we no longer have square roots. Okay. I want to prove that this is true. Prove that tangent of pi minus 3 pi over 2 is negative cotangent, so this is just using my formula. So just a reminder, tangent of alpha plus and minus beta equals tan alpha plus and minus tan beta over 1 minus plus tan alpha tan beta. Alright, so my alpha is going to be theta and my beta is going to be 3 pi over 2. So tangent of alpha, which is theta, minus, so minus, tangent of 3 pi over 2, divided by 1, this is minus, so this is plus, these two. So tangent theta, tangent of 3 pi over 2. So let's look at 3 pi over 2 right quick. 3 pi over 2 is at the bottom of the unit circle, right here. This is 0, negative 1. Tangent is sine over cosine. 3 pi over 2, tangent is... That would even exist. I wonder if let's change that, because tangent of 3 pi over 2 doesn't even exist Interesting. Yeah, I don't think I was supposed to do that. I think I was supposed to say, I must have changed the lesson from period to period because that is not what I have later on. So let me see real quick before we move on. I think I changed my identities because I realized that it didn't work. Yeah, I changed it. In fact, I think I realized I changed it to a cosine sine thing. Nah, don't worry about it. Okay, so just scratch that. That was supposed to be something different. Okay, but I did have something else that I'm going to add on there that I see. It's not on this what I have printed, so that's okay. What I do want to do is rewrite, or given a new problem, if I asked you to tell me what this equals, tangent of 15 degrees minus tangent of 105 degrees divided by 1 plus tangent of 15 degrees tangent of 105 degrees. To rewrite that as a single expression, and then what we would do is we would say, well, we know it's a tangent. We know the two angles are 15 and 105. And in the tangent formula, whatever is, whatever the sine of the top is, that's the same thing as the interior. So that's going to be minus, so 15 minus 105. So tangent of negative 90 degrees. And we can, if you can actually figure it out, then I do want you to do that. So negative 90 degrees is again 3 pi over 2, and we just discussed the tangent of that would be negative 1 divided by 0, which would mean that the answer is undefined. Okay. Sorry about that one. I was supposed to change that and I completely forgot. Okay. And then I think that I'm good as far as that goes because okay. And that, so let's take notes over that. Let's make sure we complete your notes, and then you should be able to do all the problems in the homework. And if you have any questions, let me know.